like I said before, we are going to want to write our answers in simplest form. So I want to remind everybody how to do that. I know a lot of our calculators will do that themselves, which is perfectly fine. I do want to show you with numbers what's actually going on. That way we can see how it works with variables, because our calculator won't do the variables here. So when we're simplifying fractions, what we technically, the GCD of the numerator and the denominator has to be 1. That means that they don't have any factors in common. The numerator and the denominator have no common factors. That's what it means to be in simplest form. So if you look at our first example, that negative 15 and 69, there is a factor that they both have in common. Both of those numbers have 3 as a factor. So I could write negative 15 as negative 5 times 3. You could also write it as negative 3 times 5 or 3 times negative 5. That's fine. I know there's a couple different orders we could do that in. But the reason I chose 3 again and not like 1 times 15 is because 3 is also a factor of 69. In fact, 69 is 13 times 3. Now, anytime you have something in the numerator and something in the denominator that are exactly the same, they cancel each other out. So these 3's are going to cancel each other out. And the reason they can do that is 3 over 3 is the same thing as 1. So really, I've taken that 3 over 3 and made it 1. And when I multiply by 1, it doesn't change anything. So negative 5 times that 1 is just negative 5. And 13 times the 1 would be 13. So I'd be left with negative 5 over 13. It is probably handy to check things like this in your calculator. There are tons of YouTube clips on how to reduce fractions in your calculator. Just go to YouTube and type in your calculator name, maybe TI-84 or TI-X2S, whatever, TI-36, and reduce fractions or fractions to decimals, any of that sort of thing, and there'll be lots of calculator help available. However, we can't do ones like B in our calculator, so that's why I wanted to show you A so you could see what we're really going on here. We're going to cancel out anything that they have in common. So what I'm going to do is I'm just going to kind of expand out. I know we've already talked about these exponents. So that x squared I'm going to write as x times x. And down on the bottom, that y squared I'm going to write as y times y. And 36 I'm going to write as 12 times 3. That way I can cancel the 12s out. And if you wanted to go ahead, go through and write 12 as 2 times 2 times 3, you could do that. And 36, you would also go ahead and completely factor out. You could write it as 2 times 2 times 3 times 3, and you would get the same thing. I just know that the greatest common factor between 12 and 36 is 12, so I'm going to use that greatest common factor. It's a little bit faster, but you could use any factor if you wanted to. Just might take a few more steps. Now I'm going to cross out anything that would be the same in the top and bottom. I could only cross out one x because there's only one x that's in both the top and bottom. Same thing with the y's. So what I'm left with is x and a 3y for my final answer. Now these last two involve some factoring. And I know it might have been a second since you did any factoring, so I want to kind of walk you through those. I'm going to start with C, and I'm going to start at the denominator. I'll do the numerator in just a second. The denominator, I'm going to do what's called GCF factoring. So I'm going to pull out anything that are common in both of those terms. I'm not going to worry about the numerator, just looking at the denominator, 4a minus 4b. Both of those have a 4. So I'm going to factor out a 4. Now, in the numerator, this is a special form, and it's called the difference of squares. Difference because it's subtraction, squares because both the terms, the a and the b, are squared. So I can only do this factoring when it's the difference of squares. It has a special little formula, a plus b times a minus b. So there's the first and second term, their sum, and then their difference. And if we were to fold that all the way out, we would see that we would get back to a squared minus b squared. Now I can cancel out both of these a minus b terms. I can do that because they are being multiplied. That's a plus b times a minus b and 4 times a minus b. So that's the reason that I can do a cancel like that. So what I'm left with is a plus b over 4. I think it's probably best to leave your answer like that. You could, if you wanted to, that's a over 4 plus b over 4. I think we kind of run into some complications when we start trying to split it up. So I think it's just best and most simplified just to leave it as a plus b over 4. Last one. Let's take a look at D here. And for D, I'm going to do a GCF out of the top. So I'm going to do that greatest common factor of 12x to the fourth minus 20y. The only factor that is that works for both 12, not the only, I should say the greatest common factor for 12 and 20 is 4. So I'm going to factor out of 4. That would leave me with 3x to the fourth minus 5y. Because 3 times 4 is 12 and 4 times 5 is 20. And on the bottom, there's not really much to factor. There is both a 4 on the top and the bottom that's being multiplied. So I'm left with 3x to the fourth minus 5y over x. Now I do need to stop right there. Let me write that. X to the fourth looks a little bit more like x4, so that 4 up in the exponent. I do need to stop. That is my final answer. I'm going to write a common mistake down here, so let me recopy it. So what a lot of times people want to do is cancel out this x in the bottom and cancel out an x in the top. We cannot do that because this x did not exist in the last term in the numerator. Notice I could only cancel the 4's out when that 4 is being multiplied by everything in that factor. Basically, 4 was a factor of 12, 20, and 4. It was a factor of all 3 terms. The x is not a factor of all 3 terms. The x is just a factor of the denominator and part of the numerator. It is not a factor of that second part of the numerator, the second term. So I cannot factor out the x. Instead, I just need to go ahead and stop exactly what I have right there.